So we will kick off today with question 10. The sides of a triangle are 5.2 centimeters, 6.3 centimeters, and 9.4 centimeters, each correct to the nearest millimeter. Calculate the lower bound of the perimeter of the triangle. So remember, whenever we see this, we're looking at bounds, and wherever we see that nearest, then we're going plus or minus and half of that nearest measurement. So it's a nearest millimeter, so we're going plus or minus 0.5 millimeters. And here's the catch, of course. The question has centimeters, and this then has bounds in millimeters. So we need to have a look at it. Hold on, right. So if it's 0.5 millimeters, how many centimeters is that? Okay, so remember, to get from millimeters to centimeters, we want to divide by 10. So 0.05 centimeters. So now we can got everything in the same units. We can look at the question again. Calculate the lower bound of the perimeter of the triangle. So for the perimeter, we want to add all those sides together. So how would we make the smallest perimeter? Well, we'd have to use the smallest triangle, so we need the lower bound of each side. So let's call them sides A, B, and C. So our lower bound for A is going to be 5.2 minus 0.05. So 5.15. Our lower bound for B is going to be 6.3 minus 0.05, so 6.25. And the lower bound for C is going to be 9.4 minus the 0.05, which gives us 9.35. So now we've got the lower bound for each side. The lower bound for perimeter is going to equal 5.15 plus 6.25 plus 9.35, which is going to equal 20.75. And remember, normally we round our answers to 3 significant figures, but this is a bounds question. And when we're working with bounds, we want to be that extra level of more exact. So our final answer here is 20.75 centimeters. That is the lower bound of the perimeter for the triangle. So question 11 takes us somewhere else entirely. Write the recurring decimal 0.48 as a fraction. Show all your working. So have a quick look there. Look carefully. You've got dots on the 4 and the 8. So we have our decimal is 0.4848. Both the 4 and the 8 are repeating. And it keeps going, 48, 48, 48 forever. And we want to make a fraction that is equal to this 0.484848 carrying on. But we're just going to work with the 4 decimal places for now. So remember, when we have 2 digits that repeat, we want to multiply by 100. Because we want to move over a whole repeat. So 100F equals 48.48. But remember, there's lots of 48s hiding in the background. So we can pull in another one so that we always keep this lined up. Okay, we maintain that 4 decimal places. Because now we're going to say, well, 100F minus F would be 99F. And 48.484848 forever minus 0.484848 forever is just going to be 48. Because all these decimal points are going to cancel each other out. Fantastic. Well, we don't want 99 fractions, we only want 1. So we divide by 99 on both sides, and we end up with F equals 48 over 99. But now we've got to think nicely, because those are rather big numbers. Surely there is something that can go into both of them, and we can simplify this fraction. And we do have something. We have a 3. It's going to go into both of those. So F is going to equal 16 over 33. So our final answer is 16 over 33. Okay, so there we go. And note here also how they said show all your working. So that means if you just plug it into your calculator and 4848484848 equals and convert it, and by chance you may get 16 over 33, but you won't get any marks. Okay, they want you to show the working. They want you to know that you can actually do this yourself, not just use your calculator. Okay, so 16 over 33 would then go to a recurring decimal 0.48. So moving on to question 12. Expanding the brackets and simplifying. We've got it in the first bracket 5 minus n, in the second bracket 3 plus n. Okay, so 2 brackets, we must be careful because we're going to have to do lots of multiplications here. So we can keep track of them using FOIL. So our first would be 3 times 5. Let's see if we can get rid of that irritating bit. Okay, so 3 times 5 would give us 15. Outer, 5 times n plus 5n. Inner, minus n times 3 minus 3n. Last, minus n times plus n minus n squared. So that's the expansion. The simplification means we combine the like terms. So 15 is the only one like that, but plus 5n minus 3n, so plus 2n minus n squared. So 15 plus 2n minus n squared, we have expanded and simplified. So the next one, back to fractions again. Okay, they like to jumble all the topics up when they do these papers. Write 11 over 3 as a mixed number. Okay, it's an improper fraction, it's top heavy. So we have to think, okay, so how many times did 3 go into 11? Well, not even, we're going to end up with a mixed number, of course. So we've got 3, 6, 9, 12 is too big. So 3, 6, 9, there were 3 of them. So 3 times 3 equals 9. 11 minus 9 equals 2, which means that there are 2 left sitting on top. So our mixed number is 3 2/3. Remember how they wanted us to show all our working in the fraction question we just did? Here's another one. Without using a calculator, and this time it's in bold, it's really out there sticking, okay? Work out 1 over 4 plus 5 over 12. Show all the steps of your working and give your answer as a fraction in its lowest terms. So here we are looking at addition of fractions. So we have 1 over 4 plus 5 over 12. Now the thing is, we cannot add or subtract fractions when they have different denominators. So the first thing we need to do is to convert both of these to the same denominator. We're lucky here because 4 goes into 12, so we can convert just that first fraction and then we're ready to go. So we keep our plus 5 over 12. And this first one is going to go over 12 also. So how do we get from 4 to 12? We say 4 times 3 equals 12. So we must do that same thing to the top. So 1 times 3 equals 3. So we have 3 over 12 plus 5 over 12. We have the common denominator, so that stays the same. And then we add across the top, 3 plus 5 equals 8. But they've told us of a question to give in the lowest terms, and we can see here that we have 2 even numbers, so at least 2 goes in there, but I think even a 4 will go in. So 8 divided by 4 is going to give us 2, and 12 divided by 4 is going to give us 3. So the final answer for this one is 2/3. So we've got some nice fraction revision. Always, always remember to show every step as you're working through these questions, because that's how you're proving that you're not using your calculator. From fractions to inequalities. Quite a change. Okay, so find the integers which satisfy the inequality -5 less than 2n minus 1 less than or equal to 5. So this one's a little bit different. You've got two inequalities, but you've also been asked in the question to find the integers. Not just to find all the values or the range of values, they want just the integers that satisfy this inequality. Now, we look at the inequality and we say, okay, so there's a numbers and there's a term which has an n in it. Now there's only one n term in there. So we can go ahead and solve this as it is in place. Okay, so they work the same as equations. What you do to one side, you must do to the other. Where we have three sides to consider, we must treat all of them equally. So we want to get rid of the +1 first. So we're going to +1 here, which means we're going to +1 here, and we're going to +1 here. So -5 + 1 takes us to -4. Less than 2n minus 1 plus 1, of course, gets us to 2n. That was our ultimate goal for doing the +1. Less than or equal to 5 plus 1 gets us to 6. Now, of course, we want that n alone, so we're going to have to divide by the 2, but we must treat each piece the same. So we must divide all three of them by 2. So -4 divided by 2 is going to give us -2, less than 2n divided by 2, straight to our n, which we'd hoped for, less than or equal to 6 divided by 2 is 3. So this is now the range of values, -2 less than n less than or equal to 3. But they want the integers. So we have to now take it to the next level and we have to say, okay, what are the integers that fall in between these inequalities? So -2 is excluded, so we would have to start from -1, then 0, then 1, then 2, and then we double check. 3 is included, because it's less than or equal to 3, so there would be our 3. So the question has come through, do we need to show that +1 line of working? So things like this here, where I showed +1, +1, +1, and divide by 2, divide by 2, divide by 2. So whether or not you show them all depends on your level of comfort. They do not need to be shown because it's just part of the working out. So you can go just from this line to -4 less than 2n less than or equal to 6, and then straight to -2 less than n less than or equal to 3. So it all depends on where you are with your math journey. If you're a person who is prone to making silly mistakes, show them, because showing them is how you keep track of them in your own head. Okay, if you are comfortable and this is straightforward and it makes sense in your life, then go ahead. Okay, so if they say even without a calculator, yeah, so these sorts of things, you're doing manipulations, so we're not doing calculations. Okay, so whenever we're solving or simplifying equations, we should be showing the steps, because when we go from -5 to -4, we have shown that +1. When we go from 5 to 6, we've shown the +1. So we don't need to show it deliberately if you are at that level of working. Okay, so in this case, yes, that +1 is just to cancel out that -1. I want to get rid of the -1, and in order to get rid of something, I've got to do the opposite to it. So if I want to do the opposite, I need to do a +1, and if I do it to one piece, I have to do it to everything else. So there was quite a few questions on that one. Are we all happy now with question 14? Okay, cool. Our questions are happy, so we shall carry on with question 15. Something completely different again. Now we're going thoroughly away from numbers and really thoroughly into algebra. Fantastic place to be. Okay, so write as a single fraction in its simplest form. Okay, so we need a common denominator. But now we've got x and a y. You know, if you've got a 2 and a 3, then your common denominator is 6. Fantastic, great. X and y, well, we can use the same approach. common denominator for a fraction over x and a fraction over y would be xy. So we're going to have something over xy minus something over xy. So in order to make this first fraction into an xy denominator, we multiply the bottom by y. In order to keep it the same fraction, we must multiply the top by y also. So we would have y, x plus 1. The second fraction, in order to get the xy on the bottom, we had to multiply by x. So if we do it to the bottom, we must do it to the top. Y minus 1. Okay, so be very careful of that subtraction in the middle, hey? We must take it into account. So now let's put them together, because now when we've got a common denominator, we can combine our fractions. So we would have on top y, x plus 1 minus x, y minus 1, because it's just the same as when we subtract fractions. We do the subtraction across the top, and we keep our common denominator. But now we can see lots of x's and y's and things going on the top, and we asked for simplest form. So let's see if we can actually open some brackets here and combine some like terms. So we have xy plus y from our first brackets minus xy plus x, because we've got that negative, then all over xy. And if we look on the top, we've now got an xy minus xy, which means we just disappear them and we have y plus x over xy. So in simplest form, we would have, put them in alphabetical, it's nice, x plus y over xy. Our fraction doesn't get any simpler than that, and it is in a single fraction. So all your rules for adding, subtracting, multiplying, dividing fractions apply even when there's algebra there instead of numbers, okay? Variables just work the same. We have the same rules, and we must still obey all of those rules as we work with them. So moving on, jumping topic again, question 16 gives us the first 4 terms of a sequence, asks us to find the next term and the nth term. So whenever we see a sequence, the first thing we do is look at the difference. So from 23 to 17, we've said minus 6. From 17 to 11, minus 6, and we're starting to smile. 11 to 5, minus 6 again. Fantastic. We have a lovely, straightforward, linear sequence. So the next term again would be minus 6. So 5 minus 6 equals minus 1. So the next term we are expecting is a minus 1. Finding then the nth term. We need that expression that describes a term value in terms of its position. Well, we know we are working with a linear sequence, so then we know we are working with a n plus b. So remember, big A is our first difference. So minus 6n plus, how do we get the b? We take our first term, 23, minus our difference. So minus 6n, 23, minus 6 is 23, plus 6, so plus 29. So minus 6n plus 29, or 29 minus 6n. Okay, we can just put them in the other order in order to protect that negative sign, that subtraction in between them. So whenever we're looking at a sequence, we are looking first, do we have a common difference? And then after that, we can say, okay, well, is it a different kind of sequence? So for this question, lovely, straightforward, linear sequence. So then it's just a case of plugging into our formulas. Those formulas for sequences are well worth getting familiar with. So question 17. This now takes us to geometry. Angle work. Right, brilliant, fantastic. So, the diagram shows part of a regular polygon. The exterior angle is x. The interior angle is 29x. Work out the number of sides. So we need to think a little bit, okay? It would help if we knew what an x was, okay? Because then, of course, we know what that exterior angle is. And we know that the sum of all the exterior angles on a polygon, a regular polygon, is going to be 360. So if we can get x, we can then say how many x's fit into 360, and therefore, how many sides do we have? So, remember that an interior and an exterior angle, those always form on a straight line. So we know that 29x plus x, so that whole big angle here, is going to equal 180. So 30x, combining like terms, equals 180. Dividing by 30, both sides treated exactly the same. X equals 180 divided by 30 is 18 divided by 3, which is a mere 6. Okay, so the question has come through. Why is x written as x degrees? Okay, because if you think about it, all we're calculating is x. So let's say, in this case, x is 6, right? So if we then put our 6 we replaced, we would then have 6 degrees because it's an angle, so we're measuring in degrees. So now we have the size of that exterior angle. We know that the sum of all the exterior angles equals 360. So we then know that 360 divided by 6 is going to equal 60, and that is then the number of sides, because we have the same number of exterior angles as we have sides, because each exterior angle has a side. So we have 60 sides. Question 18. I think we've got enough time to get through this one as well. Solving simultaneous equations. Okay, making sure that you show all your working. Sorry, we've got another question just come back for 17. Are we then supposed to write it as x degrees? So using the symbol or not is going to depend on the question. Okay, so what context of the question that you're working in. In this case, the degrees symbol was given, so the x was just 6. If they asked us to find the value of the exterior angle, we would have to call it then x degrees and 6 degrees, because the degrees is not provided. In this question, the degrees is provided. So it would be just x equals 6. Okay, simultaneous equations. Remember, we have two methods. We have elimination and we have substitution. So the first thing we're looking at is which one are we using? And the key is, do we have a variable with no coefficient? And we do. We have a plain y and a plain y. So remember that then means we are using substitution. So we're going to take this and we're going to substitute in. So we would have 2x minus, instead of y, write x over 2 equals 1. Now we can solve for x. Okay, we want to get rid of that fraction. So first thing we're going to do is multiply to clear it. So 2 times 2x gives us 4x. 2 times minus x over 2, 2's cancel, minus x equals 1 times 2 is 2. So 4x minus x gives us 3x equals 2. Divide by 3 both sides, so x equals 2/3. We've then got to go and do our y. So y equals 2/3 divided by 2. So y equals 2/3 times a half. So y equals, silliness, those 2's are going to cancel, 1/3. So in this case, x equals 2/3, y equals 1/3. And we are sorted with our simultaneous equations. So the next time we carry on with this lesson, we'll start from question 19.